Hey guys, today I'm going to talk about Leetcode problem, perfect squares. So, given an integer n, return the least number of perfect square numbers that sum to n. So what is perfect square? A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. For example, 1, 4, 9, and 16 are perfect squares, while 3 and 11 are not. So if we see this example, if the given n is 12, then output should be 3, because the sum of this perfect square, the minimum count of the perfect square should be 3, because consists of 4s. So example 2 is that if the given n is 13, then output should be 2, because the 4 plus 9 is the minimum count of the perfect sum to reach the n 13. When I looked at this problem, I definitely thought I could solve this with breadth first search, or BFS. This is because we need to find all types of paths that different perfect squares sum up to given parameter n. So in this case, perfect sum represents vertices, and sum of those less than n represents the relationship between each vertex, which is an edge. For example, if we are given with n equals 12, we can create graphs with possible vertices of 1, 4, 9, which are perfect sum. By starting with vertex 1, we can add other vertices including itself to reach given parameter n. But what we want in here is the minimum usage of perfect sum. This is why we want to use breadth first search to find minimum traverse of vertices. So let's code. I'm going to code it with Python 3. So first, if we want to use the BFS, we want to create the variable parameter. And we want a queue data structure, because we want to use the BFS. And you know that we want to initialize with 0, because eventually we want to reach to the n by using the BFS. Also, we want the variable count, because this is what we want to return eventually, right? Value to return, I guess. So we want to return count eventually, which represents the minimum, like minimum number of perfect square to reach given n. And we only want to increase the count every time we traverse the level stack of BFS. What I mean by level stack is that, for example, if after we travel 0, then this is the first level stack we want to travel. After that, we increase the count. Then after 0, then we come to the next level stack, which is the edges of the original 0 level stack. There will be different edges, right? Then that's the second level stack. And after that level stack, we're gonna have another edges of those vertices, and this is the third level stack. Then it repeats. Then every time we travel each level stack, then we're gonna increase the count. Then we also need the visited variable, which has a set data structure. We need visited to prevent the repetition of edges. So if we have a same edges to travel, then it's gonna create a whole bunch of like repetitions and increase the time complexity. So this set data structure, which only contains the unique value, will prevent the future repetition when we BFS. We want to travel the edges while there's some value in the parameter. So which means that we want to travel until there is possible edge to travel. Yes. And remember that about the level stack that we talked about, we want to increase the count every time we travel each level count. To implement that, we want to create the variable called level count and set it to the length of parameter, because we want to travel the number of edges from the previous vertex. Then we want to travel those edges. So for in range level count, like I talked about, after we travel all the edges from the level count, then we increase the count by 1 in the level count for each vertices. We want to actually get the current vertex, so let's name it as current, and we get the current vertex by popping the most left value from the parameter. Then yeah, this is the current vertex. Then we want to get the edges from that current by looping from the 1 to the given n. So for I in range 1 to n plus 1. So this is for getting all the possible perfect sums on the current vertex to create the edges. So to get the possible edges. So to get the edge, let's create the edge variable, and we save the edge with the power current vertex plus power of I and 2. Adding the perfect sum to the current vertex, and because we want to reach to the given n. And if edge is bigger than n, then we don't want to travel on this loop anymore. So we'll just break. This is because when we got the n of like 5, then all the possible perfect sum from vertex 0 is 1 or 4. But the value above these values are not acceptable because we don't want edges that's over the given n. We want to reach to the n, not over n. So the looping through the value above n is unnecessary and gonna increase the time complexity. Also, else if edge equal to n, if edge equal to n, if edge actually reach the n, then we want to return the current count and increase to the 1 because we need to add the current level stack. Then else if edge is smaller than n, then this is the part where we want to add the edge to travel in the future. So this is the part where we want to add the edge to the next level stack to travel. So adding edge to next level stack. So we want to add the edge to the parameter. Oops. Append. And then also, oh, I forgot about it. So we only want to add the edge if we didn't travel that edge, because we don't want the repetition of the BFS travel. Because if you have a same edge to travel, then those edges will eventually have a same value to travel, and that's really unnecessary. So, and if edge not in visited, so if edge is not in visited, then travel in next level stack, which is paired.append edge. Also, we don't want to travel this edge again, right? So we can add this edge to the visited set. So in the next level stack, or the next parameter to travel, we don't need to travel this edge anymore because it's in the visited. After we travel all this level count, then we increase the count +1 because we traveled the one level stack and we're gonna reach to the next one. So eventually we're gonna reach n with this edge with the BFS travel, and we're gonna return the count +1. So let's review this code. So for BFS, you will need the queue data structure because you need a first in and first out data structure, and that is exactly a queue. Then you'll need a count variable to keep track of minimum number of perfect square to reach given n. And we only increase the count whenever we finish traveling of number of level counts, which is the length of parameter. We created a variable visited, which has a data structure of set to prevent the repetition of edges. So for BFS, we while loop until there's a value in the parameter, which means until there's a possible edge to travel. And we declare the level count, which is the length of parameter, the possible edges to travel. So for in range of level counts, which is the possible edges for number of edges in the level count. And after we finish this level count, we increase the count. Then we pop left in the current parameter, which is the current vertex. Then we loop through from 1 to n+1, which is 1 to n inclusive, to get the possible edges. And we declare edge as the current plus i⁻², because this is the edge that we want to travel. And if edge is bigger than n, then that's the unnecessary loop, so we break it. Else, if edge is n, this is like the answer, so we return with the previous count to the current count, so count +1. Else, if edge is less than n, and if edge is not invisited, which to prevent the repetition, then we travel in the next level stack. And we do that by adding the edge at the back of the parameter, which is append. Then we add the edge to the current visited set to not visit this edge anymore in the future. Okay, so let's submit. I'm pretty sure this is correct. Okay, I've set it. So let's see the details. Okay, so we got all the tests right. We beat 72.35% of Python 3 submissions on the runtime. I guess that's pretty good. Memory distribution is only 33% beat. because there's a much better way to manage the memory. So I hope you enjoyed my solution to solve this Leetcode problem, perfect squares. And good luck on your Leetcode and all the code interview. And have a great day.